Why are nanofluids used for better heat conduction? Imagine tiny particles so small they are measured in nanometers, much smaller than a grain of sand. These particles are suspended in a liquid to create nanofluids, which are used to transfer heat more effectively. You might wonder why adding such tiny particles makes a big difference. Well, it all comes down to how heat moves through materials. In normal fluids like water or oil, heat transfer by conduction is limited because these liquids have low thermal conductivity. That means heat moves slowly through them, but nanofluids change that game. Nanoparticles, often made of metals like copper or aluminum oxide, have much higher thermal conductivity than the base fluid. When these particles are mixed into the fluid, they create tiny pathways that allow heat to flow more easily. Think of it like adding small bridges in a river to help water move faster. These pathways boost the overall ability of the fluid to conduct heat. Another reason nanofluids work better is because of the movement of the nanoparticles themselves. They are so small that they move randomly within the fluid due to Brownian motion. This movement causes micromixing, which helps distribute heat evenly and quickly. It's like stirring a cup of coffee to spread the heat more uniformly. The particles also form a structured layer around themselves, called an interfacial layer. This layer can conduct heat differently than the bulk fluid, reducing resistance at the boundary where the particle meets the liquid. This means heat can pass through more smoothly. Sometimes, nanoparticles tend to cluster together, forming tiny networks or chains. These clusters act like miniature heat conduits, further improving heat transfer. Thermophoretic effects also play a role. When there are temperature differences at the surface of nanoparticles, it causes local temperature gradients. These gradients can drive the particles to move or cause fluid activity that enhances heat transfer. All these factors work together to make nanofluids much better at transferring heat than traditional fluids. This makes them ideal for cooling electronic devices, automotive radiators, and industrial heat exchangers. Their ability to improve thermal conductivity helps keep temperatures under control and saves energy. In short, nanofluids are used for better heat conduction because the tiny particles increase the fluid's ability to transfer heat through multiple mechanisms. They create better pathways for heat, move around to distribute heat faster, and from structures that help conduct heat more efficiently. This makes them a smart choice whenever efficient heat transfer is needed.